chemistry. The very word once conjured images of bubbling potions. Strange smells filled my uncle's laboratory. It was a place of magic, of transformation. But chemistry is not just for scientists in white coats. It is all around us, in every breath we take. It is in the food we eat, the clothes we wear. It is in the vibrant colors of a sunset. The world is a grand chemical experiment, and we are all part of it, every single day. This science, chemistry, is the study of matter. It explores what things are made of. It looks at their properties. It examines how they change. Imagine you are baking a cake. Flour, eggs, sugar, these are all chemicals. When you mix them and heat them, they change. A new substance, the cake, is formed. This is chemistry in action. It is a science of creation and change. It is a fundamental part of our universe. My own early fascination with chemistry began with lights, the bright incandescence of a gas mantle, the vivid colors of fireworks. These were chemical phenomena. They sparked a deep curiosity within me. I wanted to understand the why behind these marvels. How did simple substances produce such beauty? This guide is an invitation to share that wonder. It is a journey into the world of elements and compounds, a world that is both simple and deeply complex. Understanding chemistry helps us understand ourselves. It helps us understand the world we inhabit. From the smallest atom to the largest galaxy, chemical principles are at play. It is a field full of intrigue and discovery. It offers explanations for everyday occurrences. It also provides tools to solve some of our biggest challenges. Let us begin this exploration together. Let us unlock the secrets of the elements. Let us see the world through the eyes of a chemist. All matter, everything we can touch and see, is made of atoms. This idea is an ancient one. Greek philosophers mused about ultimate indivisible particles. But it was only much later that science truly grasped the atom. Atoms are incredibly small, far too small to see with the naked eye. Yet they are the building blocks of everything. Think of them as tiny Lego bricks. From these bricks, the entire universe is constructed. Each brick is an atom. At the center of every atom is the nucleus. It is a tiny, dense core. The nucleus contains particles called protons. Protons have a positive electrical charge. It also usually contains neutrons. Neutrons have no charge, they are neutral. These particles give the atom its mass. It is like the sun at the center of a tiny solar system. The nucleus is incredibly small compared to the whole atom, yet it holds most of the atom's weight. Whirling around the nucleus are even smaller particles. These are called electrons. Electrons have a negative electrical charge. They are much lighter than protons or neutrons. They move in specific regions called shells or energy levels. Imagine planets orbiting the sun. Electrons are not quite like that, but it gives an idea. The attraction between positive protons and negative electrons holds the atom together. This delicate balance is key to an atom's stability and behavior. The number of protons in an atom is very important. It defines what element the atom is. An atom with 1 proton is always hydrogen. An atom with 6 protons is always carbon. This number is called the atomic number. It is the atom's unique identity. It is like a fingerprint for each element. Understanding this structure is the first step. It helps us understand how atoms interact. It helps us understand how they form the world around us. The periodic table is chemistry's most important chart. It is like a map of all the known elements. Elements are pure substances. They are made of only one type of atom. The table was developed by Dmitry Mendeleev. He was a brilliant Russian chemist. He saw patterns in the properties of elements. He arranged them in order of increasing atomic weight. He also left gaps for elements not yet discovered. This was a bold and visionary step. The table is organized into rows and columns. The rows are called periods. Elements in the same period have the same number of electron shells. The columns are called groups. Elements in the same group have similar chemical properties. This is because they have the same number of electrons in their outermost shell. These outer electrons are very important. They determine how an atom will react with other atoms. It is a wonderfully logical system. Think of the periodic table as a well-organized library. Each book is an element. Its position on the shelf tells you about its genre and characteristics. For example, the elements on the far left are alkali metals. They are very reactive. Think of sodium or potassium. Elements on the far right are noble gases. They are very unreactive. Helium and neon are examples. This organization is incredibly useful for chemists. The periodic table is not just a list, it is a predictive tool. Mendeleev used his table to predict the properties of unknown elements. When these elements were later discovered, his predictions were remarkably accurate. This showed the power of his arrangement. The table continues to guide chemists today. It helps us understand relationships between elements. It helps us predict how they will behave. It truly is a cornerstone of chemical science. Atoms rarely exist alone in nature. They like to combine with other atoms. They do this by forming chemical bonds. A chemical bond is an attraction between atoms. This attraction holds them together. It allows them to form molecules and compounds. Molecules are groups of two or more atoms bonded together. Water, H2O, is a molecule. It has 2 hydrogen atoms and 1 oxygen atom. This bonding is like atoms holding hands. There are different types of chemical bonds. One common type is the ionic bond. Ionic bonds form when atoms transfer electrons. One atom loses electrons and becomes positively charged. Another atom gains electrons and becomes negatively charged. Opposite charges attract. This attraction forms an ionic bond. Table salt, sodium chloride, NaCl, is an example. Sodium loses an electron to chlorine. This creates a strong bond between them. Another important type is the covalent bond. Covalent bonds form when atoms share electrons. Instead of one atom taking electrons from another, they share. This sharing also holds the atoms together. Water is a good example of covalent bonding. The oxygen atom shares electrons with 2 hydrogen atoms. Many common substances are held together by covalent bonds. Think of sugar, plastics, and even the DNA in our cells. Sharing creates a strong connection. These bonds are the basis of all chemical structures. The way atoms bond determines the properties of a substance. It affects its shape, its melting point, its reactivity. A diamond is very hard because of its strong covalent bonds. Graphite, also made of carbon, is soft because its bonds are arranged differently. Understanding chemical bonds allows us to understand why materials behave the way they do. It allows us to create new materials with specific properties. It is a fundamental dance of the elements. Section 5. The Alchemist's Dream, Unveiling Chemical Reactions. Chemical reactions are processes where substances change. Old bonds between atoms break and new bonds form. This results in new substances with new properties. It's kind of like taking apart Lego structures and building something new. The starting substances are called reactants. The new substances formed are called products. Chemistry is largely the study of these transformations. It's a constant rearrangement of atoms. There are many types of chemical reactions. One type is a synthesis reaction. 2 or more simple substances combine to form a more complex substance. For example, iron and sulfur can react to form iron sulfide. Another type is a decomposition reaction. A complex substance breaks down into simpler substances. Hydrogen peroxide slowly decomposes into water and oxygen gas. This is why it fizzes when you put it on a cut. Energy is always involved in chemical reactions. Some reactions release energy. These are called exothermic reactions. Burning wood is an exothermic reaction. It releases heat and light. Other reactions absorb energy. These are called endothermic reactions. Photosynthesis is an endothermic reaction. Plants absorb energy from sunlight to make glucose. This energy change is a key feature of any chemical transformation. The pop of a firecracker or the coldness of an instant ice pack are results of this. Chemical equations are used to describe reactions. They show the reactants and products. They use symbols and formulas. For example, the burning of methane gas is CH4. Plus 2O2 reacts to form CO2 and 2H2O. This equation tells us that methane reacts with oxygen, producing carbon dioxide and water. These equations must be balanced. The number of atoms of each element must be the same on both sides. This reflects the law of conservation of mass. Matter is not created or destroyed in a chemical reaction. Section 6. Chemistry in our daily bread. From kitchen to cleanliness. Our homes are full of chemistry. The kitchen is a wonderful laboratory. Cooking involves many chemical reactions. When you bake bread, yeast performs fermentation. This produces carbon dioxide gas. The gas makes the bread rise. When you fry an egg, the proteins in the egg white denature. They change their structure due to heat. This causes the egg white to turn solid and white. Even dissolving sugar in tea is a chemical process, a physical change involving solutions. Cleaning products also rely on chemistry. Soaps and detergents help remove dirt and grease. They have molecules with 2 different ends. One end is attracted to water, hydrophilic. The other end is attracted to oil and grease, hydrophobic. This allows soap to surround greasy particles. Water can then wash them away. Bleaches use chemical reactions to break down colored substances. This makes stains disappear. These are powerful chemicals working for us. Think about the materials in your home. Plastics are made through chemical processes called polymerization. Metals like aluminum in your pans or copper in your wires are products of chemical extraction and refinement. The fabrics in your clothes, whether natural like cotton or synthetic like polyester, have distinct chemical structures. These structures give them their specific properties. Durability, comfort, or resistance to water are all due to chemistry. Even the air we breathe is a mixture of gases. Its composition is vital for life. Batteries power many of our devices. They use chemical reactions to produce electricity. Inside a battery, chemicals react to release electrons. These electrons flow through a circuit. This powers your remote control or your phone. When the chemicals are used up, the battery stops working. Rechargeable batteries allow these reactions to be reversed. Chemistry is truly at work silently and efficiently in countless everyday objects and processes. It makes modern life possible. Section 7. The Healing Art. Chemistry's role in medicine. Chemistry is the backbone of modern medicine. Many medicines are chemical compounds. These compounds are designed to interact with our bodies. They can fight infections. They can relieve pain. They can control chronic conditions. The development of new drugs is a complex chemical process. Scientists must design molecules that target specific disease pathways. They must also ensure these drugs are safe and effective for patients. Consider antibiotics. These are chemicals that kill or inhibit the growth of bacteria. Penicillin, discovered by Alexander Fleming, was a milestone. It is a natural product made by a mold. Chemists later learned to synthesize and modify penicillin. This created a range of powerful antibiotics. These drugs have saved countless lives. They have transformed the treatment of bacterial infections. This is a triumph of medicinal chemistry. Diagnostic tools in medicine also rely heavily on chemistry. Blood tests measure the levels of various chemicals in our blood. These levels can indicate health problems. For example, high blood sugar levels can indicate diabetes. Medical imaging techniques like MRI scans often use chemical contrast agents. These agents help doctors see specific tissues or organs more clearly. Chemistry provides the tools for both diagnosis and treatment. It allows for a deeper understanding of the body's functions. The future of medicine is closely linked to advances in chemistry. New fields like nanomedicine are emerging. This involves using tiny engineered particles to deliver drugs or to target cancer cells specifically. Understanding the chemistry of our genes and proteins is also crucial. It opens doors for personalized medicine. Treatments can be tailored to an individual's unique genetic makeup. Chemistry offers hope for tackling many diseases that still challenge us today. It is a science of healing and progress. Section 8. Caring for our world. Chemistry and environmental stewardship. Chemistry plays a dual role in relation to our environment. On one hand, some chemical processes have caused pollution. Industrial emissions and certain pesticides have harmed ecosystems. Understanding these negative impacts is the first step. Chemists study how pollutants spread. They investigate their effects on air, water, and soil. This knowledge is vital for addressing environmental problems. We must learn from past mistakes. On the other hand, chemistry offers solutions. It provides tools to monitor and clean up pollution. For example, chemists develop sensors to detect pollutants in real time. They design methods to remove contaminants from water. Catalytic converters in cars use chemistry. They convert harmful exhaust gases into less harmful substances. Chemistry is essential for remediation and restoration efforts. It helps us heal the damage done to our planet. A key area is green chemistry. This is a philosophy of designing chemical products and processes. The aim is to reduce or eliminate the use of hazardous substances. It focuses on sustainability. This means using renewable resources. It means designing products that biodegrade safely. It means minimizing waste. Green chemistry seeks to prevent pollution at its source. It is a proactive approach to environmental protection. Many industries are now adopting these principles. Chemistry is also vital for developing sustainable energy sources. Solar cells convert sunlight into electricity using special chemical materials. Batteries for electric vehicles rely on advanced chemical engineering. The quest for cleaner fuels like hydrogen involves complex chemical research. By understanding and applying chemical principles, we can move towards a more sustainable future. Chemistry can help us live in better harmony with our planet. It is a science for a healthier Earth. Section 9. The adventure continues, your own chemical exploration. Our journey through the basics of chemistry is drawing to a close. We have seen how chemistry explains the world, from the tiniest atom to the grandest cosmic event. We have touched upon its role in our daily lives, in our kitchens, our medicines, and our environment. Chemistry is not just a subject in a textbook. It is a living, breathing science. It is constantly evolving, with new discoveries made all the time. The wonder that chemistry first ignited in me as a boy has never faded. The colors, the smells, the transformations, they still hold a deep fascination. I hope this brief exploration has sparked a similar curiosity in you. There is so much more to learn. The periodic table holds many more stories. The dance of molecules can be infinitely complex and beautiful. The potential for new chemical creations is boundless. Perhaps you will be inspired to conduct your own simple experiments, with proper safety, of course. Observe the rusting of iron. Watch sugar dissolve and then reappear as crystals. Notice the chemical changes when you cook. These small observations are the A, B, C of chemical understanding. They connect abstract concepts to tangible reality. The world becomes your laboratory. Every material, every process has a chemical story to tell. The study of chemistry is an adventure without end. It is a quest for understanding the very fabric of existence. Whether you pursue it formally or simply remain a curious observer, embrace it. Ask questions. Seek answers. The principles of chemistry will enrich your understanding of everything around you. The secrets of the elements are waiting. They are waiting for those with a keen eye and an inquisitive mind. The chemical journey is yours to continue.